All right, welcome back, everybody. Hope you got a little extra rest this past week. I just wanted to do a quick recap of what we had been looking at prior to going on break. So the graph above here represents a softball that has been thrown with an initial velocity of 32 feet per second and from a height of 5 feet above the ground. So the equation for this function, and I'm going to call it function f, so the function f dependent on time is going to be the equation negative 16 t squared plus 32t plus 5. And if you think back to well before vacation, we had talked about what these three numbers are. So the negative 16 being gravity, negative because it's pulling it back down to Earth. The 32t, that 32 we said was our initial velocity. And the 5 is the height above ground when the ball is initially thrown. So let me clean this up a little bit. So we're going to look at what is some of the information we can get from this graph if we know some input values, and what is some information we can get if we know some output values. So let's start with input values. So an input would be an x value. So all of these x values are inputs. And let's say we want to know the height of the ball at time 0. So we would want to know what is the value of this function at time 0. And if we look at our graph, here is time 0, and the height of the ball would be here. Now from this graph, we would have to estimate it, and we might say that it's 6, partway between the 4 and the 8. But we know from our equation and earlier conversations that the initial height is actually this constant right here. So the height of the ball at time 0 for this particular situation is 5 feet above ground at time 0. We could do a similar evaluation if we wanted to know what's the height of the ball at time 2. So in 2 seconds, how high is the ball above the ground? Well, here's 2 seconds. And so again, we would have to estimate, and it looks like it's a little more than 4, maybe not quite as high as the starting one. So maybe we say it's 4.5. But again, we're just estimating, right? We don't have any way to actually know other than to evaluate this graph and estimate what number the height is at. Okay, so that's if we know an input. We put it in and we look at the x number that they're giving us and we evaluate what the particular height of this item is, in this case a softball. And we can tell over here when time is 2, the ball is on the way back down to the ground, right? Versus over here on this side of the parabola, the ball is on its way up. It reaches its maximum at the vertex and then it comes back down to the ground somewhere between 2 and 2.5 seconds. Somewhere between 2 and 2.25 seconds, right? Halfway between, this would be 2 and 2/4, 2.25. Okay, so that's enough about inputs. Let's talk about outputs. So the output is your y value. So all of these values are outputs. And if I said to you, I want to know how high or when is this ball 0 feet off the ground? So I don't want to find time anymore. I want to know at what time is the height 0, meaning when is the ball on the ground? Well, from the graph, we only get one of those values. There is only one place that this parabola shows us being on the ground, and that is right here. And so again, we're going to have to estimate it somewhere between 2 and 2.25. So we might say that that happens at a time of, I don't know, 2.15, let's say, okay? I could do a similar evaluation if I said, well, when is the ball 8 feet off the ground? So at what time is the ball 8 feet off the ground? So I'm going to come over here to my graph, and I'm going to find a height of 8 feet, which is right here. And you can see that these points have already been labeled for us. So we have a height of 8 feet right here. And if I travel this 8 line all the way across, the parabola hits it again here. So there are actually 2 times when this ball is 8 feet above the ground. One of those times is at 0.1 seconds when the ball is on its way up. And then the other time is at 1.9 seconds when the ball is on its way back down to the ground. Okay, so that's how you can use x values to find y values and how you can find y values to find x values. But it's all done by estimation. And ultimately, what we'd like to be able to do is find exact values, right? So if we wanted to know exactly when is this ball going to be 8 feet off the ground, we would have to solve this equation. We would have to solve negative 16 t squared plus 32t plus 5. We want this height to be 8. And that's something we haven't learned yet. So that's going to be the focus for this last week. We are going to learn different ways to solve quadratic equations using some algebra skills. Okay, but for today, your assignment is focusing on interpreting the graph, and I know you're all going to do great with that.